On September 5, 1977, humanity hurled a 1,590-pound spacecraft into the infinite void on a one-way journey to eternity. Constructed from metal, gold-plated records, and 1970 circuits, Voyager 1 was launched as a cosmic message in a bottle. Today, nearly 5 decades later, it continues its silent exodus, currently over 15 billion miles from Earth, making it the most distant human-made object in existence. But here's what most people catastrophically misunderstand. The story doesn't end when Voyager's power dies in the 2030s and its radio falls silent. That's merely the prologue to its true odyssey. Today, we're tracing Voyager 1's trajectory, not just decades, but millennia, hundreds of millennia, even billions of years into an incomprehensible future, calculating exactly where this frozen monument to humanity will drift long after our civilization has vanished from the cosmos. Voyager 1 is slowly dying from energy starvation. The spacecraft runs on 3 radioisotope thermoelectric generators, RTGs, essentially plutonium-238 spheres generating heat through radioactive decay, which gets converted to electricity. But physics is unforgiving. Plutonium-238 has a half-life of 87.7 years, meaning power output steadily declines. NASA loses approximately 4 watts of power annually. Engineers have performed desperate triage, shutting down heaters, instruments, and systems one by one to conserve every precious watt. The mathematics are brutal. Around 2025 power drops below the threshold to operate even a single science instrument. By 2030 to 2036, there won't be enough energy to transmit signals back to Earth. Temperatures will plummet to minus 459 degrees Fahrenheit, near absolute zero. At that moment, Earth's radio telescopes will receive the final, faint whisper from deep space. Then, silence, permanent and total. Voyager transitions from active spacecraft to ghost ship, a frozen relic hurtling through the void, carrying humanity's message to no one. Enjoy deep, fact-checked space stories? Hit subscribe and activate the notification bell. Otherwise, YouTube will not show you the next videos, and you'll miss what we uncover next. Most people believe Voyager 1 has already escaped the solar system. This is technically false. Yes, in August 2012, Voyager crossed the heliopause, the boundary where solar wind ends and interstellar medium begins. This made global headlines. But crossing the heliopause doesn't mean leaving the solar system. The true boundary is the Oort cloud, a massive spherical shell of icy objects bound by the sun's gravity, extending roughly 5.88 trillion miles outward. Currently traveling at 38,000 miles per hour, or 10.5 miles per second, Voyager 1 won't reach the Oort cloud's inner edge for another 300 years. It won't fully exit the Oort cloud for approximately 30,000 years. Think about that scale. When Voyager truly leaves our solar system, human civilization will likely be unrecognizable or extinct 300 centuries from now. Over the next 3 centuries, Voyager 1 drifts through the local interstellar cloud, a region with slightly elevated hydrogen and helium density. By 2100, it reaches approximately 16.5 billion miles from Earth. By 2200, about 22 billion miles. By 2300, roughly 27 billion miles distant. Light from Earth now takes over 1.5 days to reach Voyager's position. During this era, the probe remains structurally intact. Space is nearly perfect vacuum. No air resistance to slow it, no weather to erode it, no oxygen to rust it. The primary threat is micrometeorite impact. But given space's vast emptiness and Voyager's tiny cross-section, collision probability remains remarkably low. Scientists estimate the probe could drift undamaged for millions of years before encountering anything substantial. In approximately 40,000 years, around the year 42,025 AD, Voyager 1 makes its first close approach to another star. It will pass within 1.6 light-years, 9.4 trillion miles, or 15 trillion kilometers, of Gliese 445, a small dim red dwarf star in the constellation Camelopardalis. This isn't particularly close by stellar standards. For perspective, Alpha Centauri sits 4.37 light-years from Earth. Voyager passes Gliese 445 at less than half that distance, but it's still immensely far. To grasp this scale, 1.6 light-years equals roughly 100,000 times the Earth-Sun distance. Voyager will be completely unaffected by Gliese 445's gravity. It simply glides past this faint red star in the darkness, an ancient artifact from a long-extinct civilization passing silently through someone else's stellar neighborhood. By this point, 40 millennia will have elapsed. Human civilization could have risen and fallen dozens of times. We might have colonized the galaxy or vanished entirely. Yet Voyager continues its ballistic trajectory calculated by engineers in 1977, completely indifferent to whatever happened to its creators. Fast forward to 200,000 years from now, Voyager 1 will have traveled approximately 17.6 trillion miles from its origin. It's now at a distance comparable to Proxima Centauri, yet nowhere near any particular star system. The Milky Way's stellar density in our galactic neighborhood is remarkably sparse. Stars are separated by light-years of empty cosmic desert. Voyager drifts through this void utterly alone, a silent monument to a species that might not even exist anymore. By 296,000 years, Voyager 1 passes within 25 trillion miles of Sirius, the brightest star visible from Earth's night sky. Again, this is no close encounter, just another distant passage. At this timescale, continents on Earth will have shifted dramatically. Ice ages will have come and gone multiple times. Mountain ranges will have eroded completely. Entire species will have evolved and gone extinct. Yet Voyager's course remains precisely as calculated. It's following the exact trajectory determined by slide rules and early computers in the 1970s. Wait, you're probably thinking, this is getting absurdly distant and abstract. Hundreds of thousands of years into an incomprehensible future. But here's where the timeline becomes genuinely mind-shattering. Because we haven't even discussed what happens over millions of years, when entire stellar generations are born and die, or billions of years when galaxies themselves collide and stars burn out. So stay with me, because the truly cosmic timeline, the one that makes all of human history look like a fleeting microsecond, that's what comes next, and it's absolutely staggering. At the 1 million year mark, Voyager 1 will have traveled approximately 88 trillion miles from Earth. It's deep into the galactic neighborhood, potentially passing within a few light years of various dim red dwarf stars humans never bothered cataloging. The probe remains structurally intact. Metals don't decay in vacuum. Circuits don't corrode without oxygen. Even the famous golden record containing sounds and images of Earth from 1977 remains technically playable, though there's no one and nothing to play it, just an eternal archive drifting through the void. By 10 million years, the distance reaches roughly 880 trillion miles. At this timescale, we must consider galactic dynamics. Stars don't remain fixed. They all orbit the Milky Way's galactic center at different velocities depending on their distance from the core. Our Sun completes one galactic orbit every 225 to 250 million years. Over millions of years, Voyager's trajectory relative to the Sun will appear to curve. Not because Voyager changes direction, it has no propulsion, but because the Sun and all surrounding stars are independently orbiting the galaxy at different speeds, creating complex relative motion. Voyager maintains its straight-line path while the universe moves around it. Jump forward to 1 billion years. Voyager 1 will have traveled roughly 8.8 quadrillion miles. At this incomprehensible timescale, the galaxy itself has changed. Many stars visible from Earth in 1977 will have exhausted their fuel and died. New stars will have formed from collapsing gas clouds. Entire stellar generations will have been born and extinguished. Yet Voyager continues unchanged. It's now older than most stars it passes. Our Sun itself faces mortality. In approximately 5 billion years, the Sun will exhaust its hydrogen fuel, swell into a red giant consuming Mercury, Venus, and possibly Earth. then collapse into a white dwarf. By this point, Voyager will be roughly 44 quadrillion miles from where the Sun once was. It will be completely oblivious to its creator star's death. It won't receive any signal, won't be affected by any gravitational change. It will simply continue its eternal drift through the galaxy, carrying evidence that Earth and humanity once existed, long after both have been incinerated. Even more staggering, in approximately 4 billion years, the Milky Way will collide with the Andromeda Galaxy. This cosmic merger will take hundreds of millions of years, gravitationally rearranging billions of stars. But remarkably, Voyager will likely survive unscathed. Despite billions of stars involved, the distances between individual stars are so vast that direct stellar collisions are extremely rare. Voyager will drift through this galactic collision like a grain of sand passing through two clouds of dust, untouched, continuing its journey through whatever new galactic structure emerges from the merger. The cosmos itself has a timeline. Current cosmological models suggest the universe will continue expanding. Eventually, all stars will exhaust their fuel. Galaxies will drift apart. In trillions of years, the universe enters what physicists call the degenerate era. Only dead stellar remnants remain: white dwarfs, neutron stars, black holes. No new stars form. The cosmos goes dark.
Even in this dying universe, Voyager persists. Structurally, it could theoretically survive for quadrillions of years or longer, eventually over unfathomable timescales measured in 10 to the power of 30 years or beyond. Even the probe's atoms might decay through quantum processes, or it could eventually fall into a black hole, or be torn apart by tidal forces near a neutron star. But these events are so far in the future, billions of times longer than the current age of the universe, that they become purely theoretical. For all practical purposes, Voyager 1 is eternal. What's truly haunting is this: Voyager 1 will likely outlast all evidence of human civilization on Earth. Wind, water, and geological processes will erase our cities, monuments, and artifacts within a few 100,000 years. Continental drift will eventually destroy even our deepest structures. Earth itself will be consumed when the Sun dies in 5 billion years. But Voyager, frozen and silent, will continue carrying the golden record through the void, the last remaining proof that humanity existed. A message in a bottle that will never be found, drifting forever through an increasingly empty cosmos. So how far will Voyager 1 actually travel before it stops? The answer is, it never stops. It's moving at 10.5 miles per second, and there's nothing in the vacuum of space to slow it down. No air resistance, no friction, no forces acting on it besides the extremely weak gravity of distant stars that it never approaches closely enough to significantly affect its trajectory. Voyager 1 will continue traveling essentially forever, accumulating distance infinitely. In 40,000 years, it passes Gliese 445. In 300,000 years, it drifts past Sirius. In millions of years, it wanders the galactic neighborhood. In billions of years, it outlives the Sun itself. In trillions of years, it drifts through a dead universe. The distances become meaningless, the timescales incomprehensible. At some point, we're not even discussing a spacecraft anymore. We're discussing a cosmic monument, a tombstone for humanity, carved not in stone, but in velocity and trajectory, continuing endlessly through space, long after everything that made it, everything that knew about it, everything it was built to study, has vanished into entropy. That's the true answer to how far Voyager will travel, not a distance, but a duration, forever. Voyager 1's journey is eternal, a testament to human curiosity and engineering excellence, drifting through the cosmos long after we're gone. But here's a fascinating question. What if Voyager could somehow reach another star system? What if, by some cosmic chance, it approached Alpha Centauri or another stellar neighborhood? What would happen? Check out my video on the mystery of Voyager's potential encounter with this planetary system, because the possibilities are absolutely fascinating.